Hi, my name is Pomulemo Tamafe.
And I'm Dupi Mashele.
Electric geysers account for the largest portion of the electric energy consumption in South Africa. 40% of the residential sector consumption is due to electric geysers.
That being said, the government issued regulation that all hot water storages have a higher insulation rating due to the reduction of heat loss through the surface of the geysers.
In light of the issued regulations, we sought to estimate the energy saved by electric geysers in South Africa as a result of a move into a more efficient insulation rating.
We also sought to demonstrate that the standing loss per se is not sufficient efficiency metric for renewable solar water heaters.
In this presentation, we will take you through the standing loss test, which we have done to characterize the energy efficiency of electric geysers. We will also present an aggregate model that estimates the energy saved by electric geysers as a result of a more efficient insulation rating.
We also present a solar geyser model to validate our claim that the standing loss on its current form is not sufficient for rating the energy efficiency of the solar geysers.
In the standing loss test, we measure the amount of heat energy lost through the surface of the geyser per day. It is standardized by the South African National Standards or SENS 151.
The standing loss test is carried out over 2 days, and the temperature response of the geyser is monitored and used to compute the standing losses and put the geyser into a specific insulation rating. With Class A,
we calculated the energy saved when moving from Class A to Class B insulation rating, and we find that it's approximately equal to 1.4 kilowatt hour per day.
The aggregate model takes experimental data as input, then it simulates the behavior of 6.9 million geysers that are approximated to be on the South African grid. Then it aggregates the standing losses of these heaters, and as expected, the standing losses do decrease when moving from Class D to Class B.
The new regulation has negative impact on solar geysers and hinders them from entering the market. In this phase of our project, we investigate the impact of taking the solar geysers back to Class D. A solar geyser and an electric geyser were both simulated on a Transys software. When comparing the energy consumption by the geysers shown on the screen, we found that the Class D solar geyser still saves up to 30% of the total electrical energy consumed by the Class B electric geyser.